We are going live. We are waiting for the confirmation of the link and the broadcasting. This is TWIS. This Week in Science, episode number 628, recorded on Wednesday, July 19th, 2017. Afterbirth Science Theater. Hey everyone, I'm Dr. Kiki, and tonight on This Week in Science, we are going to fill your heads with space music, sad birds, and so much placenta. But first,
disclaimer, disclaimer, disclaimer. Despite anything you may hear to the contrary, we humans originated on Earth. We evolved from the great magnitude of fauna the Earth has produced over 4 billion years. We were forged in the fear of predation, where any miscalculation of risk might be our last, and in the cunning adaptations of the hunt, learning how to catch prey in more and more inventive ways. We are every bit the animal our ancestors were. Beasts with brains, but beasts all the same. And while all manner of modernity over the years has sought to claim itself civilized, every modernity of thought has kept the core conclusions of predator and prey, that it is better to run and hide than it is to be eaten, that it is better to fight and kill than it is to go hungry, and that it is better to eat than to be eaten. And while we struggle to construct modernity after modernity based on anything other than these principles, one aspect of our modern age does seem to buck the trend of animal instinct, because only recently have we as a species, a society, and a civilization, only now have we earthlings discovered, for no earthly reason at all, This Week in Science, coming up next.
I've got the kind of mind I can't get enough. I want to learn everything. I want to fill it all up with new discoveries that happen every day of the week. There's only one place to go to find the knowledge I seek. I want to know what's happening. What's happening? What's happening this week in science? What's happening? What's happening? What's happening this week in science?
Good science to you, Kiki and Blair.
and good science to you, Justin, Blair, and everyone out there. Welcome to another episode of This Week in Science. We are back yet again to talk about all the science news that we see fit to talk about. Because you know what? It's our darn show. Well, you know what? It's your darn show, too. We thank you so much for being here with us for another week of science news. And we are also joined today by Jessica Hebert. She is going to talk to us all about placentas. It's going to be very exciting.
Hello. Good science.
There's going to be all sorts of fun things. Yes. In addition to our interview with Jessica, we are also going to be talking about news stories about NASA, space discoveries, movies in DNA and from DNA, and world robot domination. Crazy robot arm.
Uh-oh.
Crazy robot arm dominating the world. There we go. Jessica, I'm looking forward to your interview. Justin, what do we have from you? Oh, he went away. Where'd he go?
Who even knows?
Who even knows? He was here for a moment and now he's gone. Blair, what is going to be in the animal corner?
Oh, I brought Birds in Peril, as you had mentioned previously, and also a good examination of why exactly I distrust squirrels.
You have good reason to distrust squirrels.
I do, and we're going to talk about some science behind it this evening.
I love it. That's great. And you know what? I can't introduce Justin's stories for him, and he has run off for a moment, so we're just going to go on with the show because
he brought some ancient human stuff and some other stuff. I don't know. Justin-y things.
Justin-y things. That's right. But it's time to go on with the show. So for our first segment of the show, we are going to read from the mailbag for this week in What Has Science Done For Me Lately? Well, this is from patron Eric Knapp. Hello, Kiki Blair and Justin. I am alive because of science. When I turned 50, I had a colonoscopy, a test developed by and recommended by medical science. The test found cancer. I then had a bunch of scientifically designed scans, CT, PET, and MRI, to figure out the size of the tumor and if it had spread. For treatment, I had radiation with a very advanced machine, surgery, and then chemotherapy, all developed by scientists and physicians. I am now 3 years from the end of treatment. I am being monitored using CT scans and advanced blood tests. So far, there's no sign of the return of the cancer. So, what has science done for me? Is it saved my life. Eric Knapp. Eric in AK in the chat room. And he's in there right now. Thank you for watching the show. Thank you for being a patron. And thank you so much for sharing your story of how science has very dramatically impacted your life, Eric.
Thank
really
you,
do
Eric.
appreciate
Best
it.
of luck to you over the rest of your treatment. And we're so happy that science has been here for you.
Yeah. Maybe that cancer, that darned cancer won't come back. That would be the best thing. But we will keep monitoring thanks to science.
Yes.
Everyone out there, remember, we need you to write in to let us know what science has done for you lately. How has it helped you in your life? What does it do in your life that you think about every once in a while and you go, that's because of science. Huh. When you think about that, send me a Facebook message. Go to the This Week in Science Facebook page and send me a note. Write me a little message and I will put you in the schedule to be read on the show. You can also send me an email at kikifinch@gmail.com because I still haven't fixed my This Week in Science email because this is me and internets.
Boo science, fix Kiki's email.
I know.
Science, fix it.
The good and the bad of the science of the internets. Anyway, I want to fill this segment every week with something from our minion community, so I do need you to continue writing in. Your stories have been touching, funny, insightful, wonderful in so many regards, and I just want to keep this going. Let's keep sharing. Let's build our community, and let's remind ourselves and everyone who might come and across this show what science does for us on a regular basis. Write us. Do it. Do it, do it, do it. Now, I would like to introduce our guest. Jessica Hebert is a biology PhD student at Portland State University in Portland, Oregon. Not in Portland, Maine. It's Portland, Oregon. She studies the placenta. Jessica enjoys teaching and hopes someday to have a research lab and teach at a primarily undergraduate institution. She also does science communications. She serves on panels. She manages conferences. She does podcasts like this one. And she's also the media and outreach coordinator for PSU's Biology Investigations and Outreach Organization. She invited me last year to come speak at their Darwin Days events. That was pretty cool. And she also is very nerdy, which we can appreciate. She makes music about science, Doctor Who, zombies, and certain individuals' derrieres with her band, the PDX Broadsides. And she also collaborates with people on Facebook's theme music. And she is sometimes a pirate. And we're going to talk about all these things today. I do hope. I do hope. Jessica, thank you so much for joining us today.
Well, good science. Thank you so much for having me. It's such a pleasure.
Yeah. So the last time our paths crossed, you had a bucket and a super soaker.
Yeah, that'll happen when you study placentas.
Explain what buckets and super soakers have to do with placentas.
Okay, so if you've never seen a placenta before, they're gross. They're they're about 20% of the weight of a human baby, so they're between 1 and 2 pounds at birth. And placenta is Latin for flat cake because that's what it looks like. But the placenta is this, yeah, you already learned things.
I did, and it just gives new meaning to the placenta eaters.
That's the hashtag Team Placenta promise. We'll get to placenta eating.
All right.
Yeah. So the placenta is a system of blood vessels, and it is responsible for transporting blood and nutrients and waste and gases in between mom and the baby. And when you've got all these blood vessels, well, you can look at the super soaker as a model for moving fluid. There's a condition called preeclampsia, which affects up to 10% of all human pregnancies, and it's a problem of high blood pressure. It's not a change in the amount of flow going through the placenta, but the pressure, the rate of flow going through the placenta. So the super soaker, the volume doesn't change, the amount of liquid stays the same, but the rate at which it flows through is going to change based on how much pressure it is. And much like us, babies don't like getting hit in the face with high velocity blood flow. So having a super soaker pumped up really full, high pressure is a pretty good indication of what preeclampsia looks like. Also, for a 3-minute speed talk, audiences are terrified when you come out with a super soaker, so you have their attention
at the same time. At any moment.
I might get squirted with a placenta. Things that you never thought you would say until you come to one of my talks. So that was at OMSI for Science Talk Northwest, the 3-minute trainee talks, and I was really honored to win the competition with a super soaker placenta. And now I've given that talk a couple of times, including at the Mission Pub last week, and I'll give it again in Manchester, England at the end of August. So it's become very popular to talk about the placenta with the super soaker. Who knew?
Popular, and it just gets at or underscores the idea of engaging people and trying to find a way to talk with people about the science that you do. And we hear this story of the scientist as the poor communicator. Obviously, you've found ways to communicate your science very effectively.
I think I've done okay. I brought a couple of props that I used during, so I'm also an OMSI Science Communication Fellow, which means we work with the public, kids, families, and then during OMSI After Dark, if you've ever been in Portland, the Oregon Museum of Science and Industry does a late night event on Wednesday nights, like the last Wednesday of the month. And so drunk people can come play with your placenta and your models. So you want to make sure that you have things that don't break. So I had a knit placenta made.
Nice.
For the drunk people and small children. And this is the umbilical cord, the fetal side of the placenta, the amniotic sac, and then the maternal side of the placenta. So that's one of the models I use, and people get really excited. They can touch it. And then the other model I use is this, which is the spiral arteries on the maternal side of the placenta. And it's a 3D printed model of all the blood, of all the arteries that control blood flow on mom's side of the placenta. This is an actual cast from a mouse, and then I blew it up. So that people can touch
that's
that.
kind of big for a mouse.
Well, it was like, it was Minnie Mouse, so it's about the right size.
Okay.
But yeah, I think models, things like the super soaker, things like knit placentas, if people can touch it and see it, 70% of people are kinetic learners. They want to touch things. They want to understand, how do things move? How do things work? So it's a really good way to reach people and make them excited about how awesome the placenta is, and weird, but great.
So let's talk about all these aspects of the placenta, the awesomeness and the weirdness. The placenta. Mammals have this placenta. Why do we have a placenta and other organisms did not evolve such a blood-sharing device?
It's weird. So eutherian or placenta having mammals, people say, oh, they're the only things with placentas. They're not. Some snakes and some sharks have placentas. They're part of convergent evolution rather than divergent, which means they developed for a shared purpose, but not from the same ancestor. So it's a placenta is an attachment point. You can even find a structure called a placenta in many fruits, like the tomato, because it's where the seeds just attach to the middle of the fruit. Why do we have a placenta? Recent research says it was a retroviral infection of the uterine lining is what caused the first placentas to form in mammals.
Whoa.
Huh.
Yeah, we're mutants. It's great.
So viral DNA got in there
Yeah,
and placenta. Ta-da!
that's the idea. The placenta is made of, this is kind of a misconception. A lot of people think the placenta is made by the mom, and it's not. It's made by the outer layer of the embryo. It's called the syncytiotrophoblast, and it's that outermost layer of the embryo that forms the placenta. The placenta is a fetal organ. So when you ask
Wow.
people, oh, who's ever made a placenta? And only like folks who have been pregnant raise their hands, I can say, no, every single one of you made a placenta because you've been born.
So I had a placenta once.
Yeah, you did.
Wow. That's awesome.
I tell you, the placenta is the best.
So in that it comes from the fetus. I mean, I know that we've had issues with blood type, the Rh factors with between mother and fetus, and rejection of the fetus or the ability of the mother to maintain a fetus within the uterine environment without the mom's immune system going, shoo, get out. So what kind of are things like preeclampsia, are these things that arise from a mismatch between the fetus placenta that it's creating and the mom's body that's attaching to it?
Yes and no. Yes, that there can be sort of a mismatch because the genes that form the placenta are primarily driven by dad's genes, what dad is able to give to the fetus, because evolutionarily speaking, it benefits dad to drive the placenta and drive fetal growth, because this is the one that he can guarantee is his, genetically speaking.
Whoa, so is there some kind of genetic imprinting going on that prioritizes the male DNA in this process?
The placenta is formed primarily because of genes that come from the sperm. So the placenta is a very metabolically greedy organ. So it wants to gain size, it wants to grow, and it pulls a lot of energy and resources away from mom. That's why pregnancy is exhausting. You're growing a human, but you've also got this placenta that's taking up a lot of energy. So yeah,
so the placenta is like the alien.
It is.
Yeah, I was I'm growing an alien in here when I was pregnant. I was then.
So is the developing fetus. The fetus is also a parasitic alien, but the placenta is a separate and equally as important alien beast.
So what exactly are you studying with respect to the placenta?
I study two factors that can affect the way that the placenta develops. One is mom. When we talk about, again, that super soaker model and the change in pressure, how does mom control that change in pressure? And there's a few ways that she can do it. If she is obese, if she lives at high altitude, there are some external factors, but we're interested in a genetic predisposition. It's an increase in a protein called angiotensinogen. And if you've ever known someone to be on an ACE inhibitor like lisinopril, very, very common, captopril, that helps shut down the effect of having too much angiotensinogen. And these moms that have too much angiotensinogen, it's a little difference in the promoter region. It's an A6 promoter variant, and we find that promoter variant in 50% of people of African descent and 30% of people of Asian descent, and it drastically increases your risk of preeclampsia. So I study the mom side, and the other thing I do is fetal sex. Boys do worse in preeclampsia. Boys are more likely to be stillborn. They're more likely to have future bad health outcomes like diabetes, shortened life expectancy, kidney failure, cardiovascular problems. So why is it that boys do worse? And why isn't it affecting girls the same way from preeclamptic pregnancy? So maternal angiotensinogen and blood pressure and fetal sex. What effect does that have on preeclampsia, and how do we fix it?
So does the fetal sex actually influence whether or not preeclampsia happens? Like, is it more likely that a male child will lead to a preeclamptic situation?
No, it doesn't seem to be more likely, but it's an increased risk in outcome.
Okay, so just the outcome itself. And then, so how do you study this? You mentioned that you had this mouse model. I'm assuming you're not going in and doing trials on human pregnant women.
Sometimes. So I do get, Oregon is one of 4 at-will states where you can do whatever you want with your placenta. Most of the other 50 states have some gray areas, but not all of them. But in Oregon, you can say, I want to donate my placenta, or I want to take it home and I want to plant it under a tree or eat it or turn it into a teddy bear, real thing. But a lot of people choose to donate them, and then we can use them for research and study them that way. Do you want to know about the teddy bear?
I want to know about the teddy bear. You have to pause it here for a second. I have to
You
know.
put it in there. That didn't just come from nowhere.
No, there's an artist. I want to say his name is Alex Green, and I feel like I'm butchering it, but he took a placenta and tanned it like you would like a leather hide, and he made a leather placenta teddy bear. It's kind of cool.
Wow. Yeah.
Yeah. There's a lot of things you can do with your placentas if you want to.
Why though?
Let's see. Some things that I've heard of people doing with their placentas that I really like. You can plant it underneath a tree, like a young tree, and then the tree grows as your baby does. The placenta is really lovely. It's got this great tree architecture. So some people, I've seen this on Etsy, they roll it in paint and they make prints of the tree and then they sell them. Real thing.
Yeah, now that one makes sense.
What else do people do with their placentas that doesn't involve eating them? They make jewelry out of it. There's a lady who makes placenta photo frames in England.
Wow.
Yeah, like lots of... If you're a do-it-yourselfer, the placenta is kind of a dream organ, I guess. But
then you also have to like go into midwifery to even like
or make a
where
friend.
Do you get all these placentas and these frames? Like, how do you do this?
I don't know. You make friends and decide to do crazy things. I don't do any of those things with placentas. I've never eaten a placenta. And someday, if I am lucky enough to have a placenta, then I will inject it with plastinate on both sides, put it in a giant block of lucite, and use it as a coffee table.
Yeah.
I'm really excited for that day. It's the long.
I'm glad you have a plan.
I do.
So that's so interesting because to me, the idea of doing that is really cool. But I don't know if I'd want a placenta out of my body there.
Hey,
I'd rather
excuse
have
me,
like a
Blair,
stranger's
Blair,
placenta.
It's not your
No,
placenta.
it's out of my body.
It's the mothers and the babies. We've determined this. It's not yours anyway. So.
Right. But
Fair
why
enough.
I want to do it is the long con. So I've got it embedded in lucite, and then when my child brings home his or her prom date, I can say, welcome, I'm Spartacus's mom, and this is a placenta that they made. It was like their first art project.
Yeah.
Actually, that's cool. Now you have me.
There we go.
That
All right.
sentence did it.
I was going to tell normal stories on This Week in Science. Hi.
No stories here. We
Good.
can get back to the normal stuff.
No, it's fine.
So you collect placentas that have been donated by women at the hospitals, OHSU here in Portland, and then you also have your mice.
I do. We also do some trials with out at the Primate Center, West Campus OHSU here in Portland. And we have done some live human trials including on our microbubble work, which is a new technology where they're little tiny bubbles about the size of a red blood cell, and they ring like a bell under ultrasound, and we can measure the flow of blood through the placenta in real time using Doppler ultrasound. And we have done that in live human pregnancy, and you can tell the difference in blood flow rate very early on. It's very cool.
Wow. And so is this technology is potentially going to be useful to help doctors to diagnose dangerous situations, to monitor them as they go on? Or is this something that's kind of like, you don't really want to do it that often?
No, it would be a great potential diagnostic tool. We can send a high frequency ultrasound pulse through and it lyses the bubbles open and mom just pees them out. It's all phagocytosis from there. It would also potentially be a very useful therapeutic tool because we can load the bubbles down with genes for direct gene delivery to the placenta and the uterus. So we've done this in mice, not in humans. We've done delivery of a gene called vascular endothelial growth factor, or VEGF, directly to the uterus. What that does is it encourages blood vessel growth. So if you don't have enough blood vessels and they're not spiraling enough, they're not spreading the blood flow out, you have a problem like having a hose with a very tight nozzle. If you have more blood vessels, more hoses, that spreads the pressure out a little bit. So VEGF helps encourage that, and we were successful in mice. So maybe someday we'll get to do it in humans.
Do you have any fun mouse research studies? I mean, do mice eat their own placentas after? I'm sure they eat their afterbirth, right?
I've never seen a mouse eat their afterbirth, but I know that like dogs and wolves, people bring this up like, well, why do sheep do it? I'm like, well, sheep do it because they're trying to defend themselves against predators.
Yeah,
Dogs do
the same reason they eat their baby's poop too, so they don't have any sign of a baby around.
Right. Yeah, it's all about defense. Some human people like to eat their placentas, and we had a case here in Portland just 2 weeks ago. It was July 3rd that that this happened. Woman had a baby, term, it's fine. Baby was born with a strep B infection. It's very, very common. They treated the baby with antibiotics, treated mom with antibiotics, sent baby home. Everything was great. 5 days later, baby comes back and is presenting with strep B infection again. Same infection. Well, that's weird. Where could this be coming from? And they were watching mom while baby's in the hospital, and she keeps popping these pills. She'd been eating placenta pills from the infected strep B placenta, and it gotten into her milk supply.
Oh,
So.
wow.
Yeah, strep B dies at like 350 degrees Fahrenheit, and when you preserve the placenta, yeah, it's like 150 degrees Fahrenheit to powder placenta and pills. So if your placenta isn't totally clean, like if you've got some sort of infection, don't put it in your mouth.
That's my motto.
And I would imagine, I mean, this is probably a fairly unregulated market. And so if you're sending if you're not doing it yourself and you're sending your placenta to a company to turn into a pill or whatever, you're just having to trust that they're doing everything in a clean way, that they're not, that their practices are sterile.
Right. The CDC's issued warnings, and the FDA, it's not FDA regulated to have your placenta turned into a pill, or I've heard of placenta lasagna, placenta pizza, placenta like everything. Some people put it into smoothies. I would be real careful. Proceed with caution. Kim Kardashian thinks it's cool, but proceed with caution.
The cannibal expert we had on the show, how did he have it? I think in a stir fry?
Yeah, I think it was stir fried or something.
Yeah. Well, there was a professional chef, I guess, that prepared it.
So we've talked a bit about preeclampsia. Or what other placenta-related problems are there that people are studying, that you're looking at even?
Lots of problems in the placenta. Mo problems. One of the really common things you'll hear about is called placenta accretia. And that's when the placenta starts to grow, and the placenta only grows at the place where the embryo implants in the uterus. It's pretty specific. But it'll find scar tissue or some problem in the uterus, and it won't stop growing. And it looks just like cancer at that point. So it grows and grows. It can even grow outside of the uterus into other organs. But it's a very interesting way to study tumors and cancer using a very temporary model. And why does the placenta usually turn off when cancer doesn't? Placentas can regulate their own growth. Yeah, so it's kind of a neat model for understanding cancer treatment.
Interesting.
Other problems with the placenta. The placenta has its own microbiology. And very recently they discovered that the microbiology of the placenta, this unique group of microorganisms, is more related to the microbiota of the mouth than the gut or anywhere else in the body. The mom's mouth determines the microbiota of the placenta.
Interesting.
I wonder how that ends up happening. How, like, the transit system must be very interesting.
We don't know, but we do know that your oral microbiota changes depending on whether you're obese or not, and that's also reflected in the placenta.
That's fascinating as well. I mean, it's fascinating in just to even consider, like I had always considered the placenta as kind of like the blood-brain barrier for the brain, where the placenta would act as the last filter, last resort protection for that, the blood supply between the mother and the baby, to make sure that nothing dangerous from the mom got to the baby. But we know that's not it. That doesn't completely work, but
not completely, but you're right. There's a membrane between mom and the baby called the chorion, and so mom's blood and baby's blood never directly intermix unless there is a wound or some sort of break in the chorion. Otherwise, it just transports nutrients and waste back and forth through that membrane.
And then do the microbes sit then on the mom's side and not pass over to the baby's side, or are the microbes throughout?
There are microbes throughout, but they don't necessarily pass all the way through. Yeah, weird.
So that's fascinating. So maybe I'm just, just thinking maybe there's a placental symbiosis going on with the microbes.
Well, I would actually, but my first thought on that would be that there was a particular virus load in the placenta that was doing the filtering. That was actively killing off bacteria other than what it sort of was going to allow to be there.
It's all a system of checks and balances. We say in humans, it's pregnancy by committee, because you have what the mom's biology is driving, what the fetal biology is driving, what dad's imprinted genes are driving. So there's a lot of crosstalk going back and forth between what's beneficial for mom, what's beneficial for baby, instead of just like in sharks, there's a placenta and a fetus, but if things aren't benefiting mama shark, then baby's going to get fewer nutrients or maybe not make it.
So do we know how the physiology, what are some of the big outstanding questions about the placenta that you're just fascinated by?
Wow. One, why placenta? Why do? How do? People have focused on the placenta for, from I would say the 50s on, it's become this question of like, oh, you're not just a waste organ, you actually do a thing. But the immune system of the placenta is pretty interesting because there's a whole set, like you brought up Rh factor, there's a whole set of CD4 recognizing cells that say, that turn on and off during pregnancy. You can get what's called a TH cell switching, so TH1 to TH2. Your cells switch from an immune profile to an allergy profile. There's a lot of questions about like, well, why is that beneficial and how does that actually work? Yeah, there are a lot of questions about how the placenta works and why it can negatively impact babies and how do we make it better. So that all feeds into my big questions of
Why
boys,
placenta, how do?
why placenta, how do, and boys, why do worse, bad, bad?
Yes. I wonder that question on the daily.
My favorite paper in all of placentadom, my favorite name of a paper is Boys Live Dangerously in the Womb. And it just goes to prove that it starts real early.
It starts very early. I mean, there are lots of studies, though, suggesting boys do physiology. I mean, a lot of it is just based on exposure to testosterone, but physiology-wise, there's men respond differently to the common cold. That actually, the common cold is like it's harder on them than women. There are also
that's why they're always complaining,
right? Yeah, there are studies that have shown that there are many things, that there are these sex-linked differences. And so this goes to show this is a big one early on. And if we can help to offset the effects of things like preeclampsia on boys, especially if it's hitting them the hardest, and that's awesome.
That's the goal. Healthy mamas, healthy babies. That's what we do.
Yeah. And then you also write music and sing songs.
I have a couple of strange hobbies, but they all kind of tie into SciComm one way or another. And one of them is I have a nerd band here in Portland. It's called the PDX Broadsides. We just had a massively supportive, awesome Kickstarter for our 4th studio album. And we funded it 278%. So we're going on our West Coast tour starting next Thursday. Don't tell my boss.
Hopefully your boss is not watching this.
I don't know, but it'll be in 3 different small chunks, so I won't be away from the lab too much.
Which is always important to your PI. You need to be studying.
There's our first 3 dates up on the screen now, I see. So Seattle is next Thursday, and then Vancouver, British Columbia will be an international touring band.
Fantastic.
And then we'll be in Portland and Salem, Lyons, Oakland, San Francisco, and Santa Rosa before the end of August. So lots of traveling and touring, and we sing about Schrodinger's cat and rocket science and Shakespeare and Starbucks and Nathan Fillion's hind parts. It's catchy. We sing about feelings and fandoms and things that we love. So sometimes they're happy and sometimes they're sad, but I mean, we love what we love, and we are very excited to share it.
I think that's wonderful. I think it's just great that you've got this, like we were talking about before the show, that you have this other thing that you do, that it's not just all placentas all the time, that you have a creative outlet. And many scientists are very well-rounded people who have other interests like music or humor or literature, and you're just falling right into that creative scientist category there, Jessica.
Well, I think that there are 3 people I'm talking to right now who go to prove that having a creative side ends up benefiting you a whole lot when you want to talk about science, but you also want to connect with a really great public audience who's excited. Like it's good to not be boring.
Yeah. Do you have any completely just science songs that you do, or it's just lots of different topics?
We have a song on our first album called Schrodinger's Cat, sung from the perspective of Schrodinger's cat. It's never any fun to be Schrodinger's cat. Yeah. He does not know whether he's alive or dead. We have a song we wrote for Dane Alt. He's an artist, Monkey Minion Press here in Portland, and he had a huge Kickstarter about 30 lesser known scientists. It's called Eureka. Beautiful book, and he had us write the theme song for Eureka. So it's all about these 30 lesser-known scientists, and the bridge is about my favorite lesser-known scientist, Rosalind Franklin. I love her so much I named my piano after her. She's my favorite. Our new album has a song about rocket science. The clean version's on the album, the dirty version's on the EP.
Oh!
You know, occasionally the after hours songs come out, but
And when you're performing live, is it the clean version or the dirty version?
it depends. Most of the stops on our tour are all ages, so clean. But we are happy to do adult shows and you know, drop some special words and themes in there for you if you like. pdxbroadsides.com. We are hireable worldwide. Bring us
International music stars.
Yes. I mean, we're about to go to Vancouver, super international.
It
But
is.
we're happy to bring the science party to you, to your ears, to your face. We're on iTunes and Spotify and Amazon and all of those places, and Bandcamp, and of course,
I've seen you on YouTube.
pdxbroadsides.com. Oh yes, we are on YouTube. Oh, good. Yeah,
We'll
we're all
forget
the
about
places.
And I have wanted to do something like that with the show, like also be a band. And Blair plays saxophone.
I do.
And that's kind of it. I play guitar a little bit.
Yeah, the baritone
And
sax is not a solo instrument.
I haven't heard the two of them sing. But Blair can't like sing and be playing saxophone at the same time, I guess. So that
Yeah,
wouldn't
that's
matter
pretty
if she
tough.
could sing or not.
Yeah.
But
Well, if you
yeah, we
need
don't
a
have-
stunt
we don't have the
ringer,
talent.
a stunt science musician ringer, just call me. I'd be happy to help TWIS out.
There we go. With
To
our
Portland.
science music dreams in Portland. That's right.
Kiki's
How come
over
whenever they're singing, they all sound like Jessica?
It's so weird.
That's so strange. Oh my goodness. I'll just sit here and mouth it, the words a little bit.
That actually
play-
might be pretty hilarious to do a music video for one of your songs where we're just pretending to be you.
I approve. Do it. Or I can like use auto tune so you'll all sound like T-Pain, and then it'll
There we
be
go.
even better.
Oh, dream come true.
Oh my goodness. And in addition to your music, you are also sometimes a pirate.
Yeah, I have dangerous hobbies.
Yes.
It happens.
Involving cannons?
I do, yeah. So that's also part of the SciComm. I teach about the science of the golden age of sail and the science of gunpowder and why it goes boom.
Oh,
And sometimes it's also just fun to dress up. It's a group here in Portland called PDXER, and we are the Corsairs of the I-5 corridor. And we have a full cannon line, fire dancing, historical sea shanties, sword fighting. We are entertaining, but also accurate-ish.
Ish.
Oh, that's
Ish.
fun. Now,
Well, I mean, we're not plundering or raiding or looting or burning your town.
yeah, it's
So
just
we're-
a matter of time.
We're a little bit more Disney-fied than, you know.
And the new Disney
Angrified.
side, like what they're doing, where I think they're going to be getting rid of one character and switching out the male pirate for a female pirate, and
Wait,
yeah,
what?
so it's even
The
gonna be-
redhead, if you've ever been to Disneyland, like the red-headed wench, who is
Yes.
part of
Right.
the
Yes.
wench
Ah.
auction,
Yeah,
is going to
give
become
me
a
the
pirate.
redhead.
Oh,
We
good
want
for
the
her. It's about
redhead.
time.
no
Yeah.
longer a wench. On to piratedom.
You know what? The red-headed wench can be a real pirate. The doctor can be female. Welcome to the revolution in
There
geeking.
it is. Yeah.
And so can Starbuck. Starbuck was one of the first, right?
Yeah, and
Yeah, and that's
as
our
a
galactic
father
line.
of two daughters, it's nice that my daughter's ecstatic that there's gonna be a girl Doctor Who. She's just over the moon. She's a huge Doctor Who fan, and yeah, she's really looking forward to that. Hey, but couldn't you combine all of these and maybe you need for a stage costume
Oh, a placenta cannon.
a placenta pirate hat. You could tan it.
Oh, like a tam with the umbilical cord coming. No. But I feel like all of these things combine really well into science communication because You know, I can be, I can sing about it. I can talk to you very excitedly about all of these things. And I'm very excited that you mentioned like your daughters and the fact that we're talking about representation, because when you see yourself represented in piracy, in nerdery, in science, when you see a scientist who looks like you, that is so powerful. You say, you know what? It's not just for old bearded dudes. You know, it's okay to be excited and want to sing and also study cool, amazing things for the world of what we know.
Yeah. My youngest, she's 4. She'll quote from the Ghostbusters movie. Like some of the like, I don't think that if she had just seen the regular, you know, with the old Ghostbusters, she'd be that drawn to it or be quoting it or want to watch it again and again, you know. But because it's because the all-girl cast, she immediately feels that connection to them. So it is
I'm
important.
so excited. Yeah, absolutely.
Keep it going. It's gonna be. I'd love to see things just a little bit more equal at some point. But you know, we're working on it. It's all good. And you are a wonderful role model. What are you doing next, Jessica? When is that PhD defense coming?
You're allowed
What's going on?
You're allowed to ask me that if you're actually offering me a job. Otherwise. So what comes next? I will be defending sometime before Christmas. So watch your mailboxes for fall 2017. You're all invited to my dissertation defense at Portland State University. I would love to continue to do what I'm doing now. I love making healthy mamas healthy babies, but I love to teach. So whatever I can do in order to understand how it is that we learn and to continue to teach and have a small undergraduate research lab, that's my dream. But I'll always be a science communicator. You can't take the sky from me. I'm going to be doing this until I die.
I hope you
I
do.
love it.
I mean, we need many scientists who are also amazing science communicators. You will be an amazing mentor to your own students in the science that you do, and also in the communication of it. And I think it's a laudable goal.
Thank you. We'll see how this goes.
I think it's going to go great, and I can't wait to see that invitation to your defense.
Me neither.
It's gonna be awesome. And then hopefully you'll be staying in the Portland area. We don't know where. Do you have any moving abouts for research that you're doing at this point, or?
I'm sort of in and out. I'm going to England the end of August for a conference, but I'm going to visit Cambridge because Cambridge has the Boyd collection. It's the largest collection of like human placental artifacts in the world. Yeah, it's amazing. They have rooms and rooms of slides that they've been collecting for decades. Different cross sections of the uterus and the placenta. So I want to go understand what's in their collection. It's never been digitized. It would be a big dream for me one day to get to go in, stain those, do 3D mounting, and show the world what's in this collection because it's absolutely incredible. So I'm open. Cambridge, call me to try doing new things as long as it's got the end goal of making healthier mamas, healthier babies, and can I make you excited about it? I'd love to stay in Portland, but you got to go where the science calls you sometimes.
You got to go where the placentas are.
I want to go where the placentas are.
My head was in the same exact song. Oh my God, you beat me to it. It just worked too well. That was amazing. All right. So where can people find you online if they want to keep track of your placental science? And hashtag Team Placenta.
Hashtag Team Placenta on Twitter. That's us. I am on Twitter. I'm at Dame_DNA. You can also find me writing pdxbroadsides.com, and I write on WordPress as Dame DNA, and sometimes about where I'm going to be and all about my science excitement. Oh, look, there's my face. It's very exciting.
Nice with
And there's
placenta.
my slightly outdated blog. I promised to write something about this encounter today. I love how you have oh right, the one where I almost murdered an appliance.
It's a funny story. If that we will have the links to your Twitter and to your blog and to PDX broadsides in our show notes.
Awesome.
And, so on our YouTube page and also at TWIS.org, we will have all of these links. And so if people want to read about how you almost murdered an appliance,
it was a lab appliance. It is science. Does it count? And I will be writing more now that we're kind of into the summer, so it's research, and I've got a couple of publications coming out. So once those are wrapped up, I'll be able to focus a little bit more on writing about why you should care about how awesome science is.
Nice. I love it. Thank you so much for joining us tonight. This has been wonderful.
Very fun visit, for sure.
Thank you so much. It's such a pleasure to talk to other people who are as excited about the wild and wide world of science as I am. And, you know, the placenta is weird, but the placenta is wonderful. Love your placenta.
Love the placenta you make. That's
because you made it.
You made it. Yes, you did. All right, everybody. This is This Week in Science. Thank you once again to Jessica Hebert, who has joined us to talk about the placenta. And again, you can find her at Dame_DNA on Twitter, and also at her blog and at PDX Broadsides. But we will have those links for you if you are interested in following her scientific pursuits and her science communication pursuits. Beyond that, it is time for us to take a very short break. We will come back in a few minutes with more This Week in Science, because you know what? The science news is up next. We've got space, we've got ancient peoples, we've got birds and Blair's problems with squirrels. And that's coming up in a few minutes. Stay tuned.
Explain the things you heard with more than intuition.
So, Jessica, at this point, if you want to hang up, you are more than welcome to just hang up on us, or if you want to stick around, you can stick around. We're going to be talking science for a little while longer. I have my little messagey things that I need to do right now. Or you can just hang up and watch, or go to sleep, because sleep is nice.
I do have some writing and things that I need to do. Were there questions in the chat box or no?
Oh yeah, somebody, Ed from Connecticut, says, don't take your placenta collection with you. TSA might ask some questions.
Oh, fair.
Yes, there was also, what was another question that somebody had? Or I think we answered some of the questions.
Oh, good. Great.
Yeah. What was that one question? This question was asking if the strep B had actually any effect on the placenta itself.
Oh, I don't know the answer to that question, so probably good.
Yeah.
Yay. I will probably go, because I do have this publication due like at the end of this week.
Oh, yes.
Yeah.
That's fun.
As much as I'd like to hang out, but I will probably have the show on and be watching from the sidelines. So
awesome.
Yeah.
So the YouTubes will be up when the show is over. Basically, show notes will be on that some point, probably tomorrow, no later than Friday. And then I'll have the podcast out probably tomorrow afternoon. And
Super.
we'll post about Friday morning. So the links, I will email you with links to things if you want to share.
I do, absolutely. And I've told some of people that I know that you might be looking for additional, especially female scientist guests. So I hope that people drop you a line. But this was delightful, and I'd be happy to come back whenever. Let me know if you want that song,
Awesome.
that collaborated song. I'll pretend to be everyone. I will
Yes.
not. I will intentionally raise my voice for Justin's part. We'll
Oh my
sing
God.
higher. As you do.
As you do it. It would be perfect. Yes, I love that idea. Okay. We will be in touch. Wonderful.
Yes. Thank you so much. It was a pleasure. And thank you, Blair and Justin, so
Yeah,
much. You guys are
absolutely.
delightful. Blair, let's meet up in San Francisco. Come to our
Yes,
show.
please. Yeah.
Yeah.
Yes. Do the thing. Where's Justin?
I don't know. He's off.
He's on a break.
He's on a break.
No, I mean, is he in San Francisco
Oh,
or?
he's in Davis.
Oh, okay. We'll have one show in Northern California, like more northern than you. I think Santa Rosa, but
Yeah.
yes, we'll see. All right. Thank you again so much. Have a great rest of your show. It'll take me a couple minutes to boot everything back up, but this has been delightful. I appreciate it so
Awesome.
much.
Yeah.
You're
Thanks
welcome.
so
Thank you.
much.
Okay. Bye, friends.
Have a good night. All right. I read now. Thank you, everyone, for watching and listening to TWIS. We really do appreciate your time spent with us every week. If you want a little bit more TWIS in your life, hey, maybe consider checking out our merchandise. Oh, yeah, that's right. We've got things that you might like to wear or put on your desk, or I don't know, pillows to put on your couch. You just have to go over to twis.org, our website, twis.org, and click on the Zazzle store link in the main header. The Zazzle store link will take you to our Zazzle store, where apparently there is a sale going on with the code Zazzapparel 40. You can get 15% off on several items, 30% off of a Blair's Animal Corner Toad t-shirt. Yeah, we've got all sorts of things, stamps, mugs, mouse pads, phone covers, aprons. There's a polo shirt in there somewhere. There are hats, all sorts of fun TWIS logo-ified items that will make your life a little bit better because you'll just have, that piece of TWIS that you can take with you or look at all the time. If it's a mouse pad at your desk, whatever, your morning TWIS coffee mug, you'll appreciate it. I know you will. So if you're interested in that, click on that Zazzle store link over at twis.org. If stuff isn't your bag, well, we appreciate everything that you do just by listening and telling people about TWIS. I mean, that is so amazing that you're here with us as part of our community. We appreciate that, number one. But if you want to be even a little bit more involved in the community, you can help us produce the show. Be an executive producer. Click on the donate button on the side of our webpage. It's a nice yellow donate button. It says support TWIS. Click on it. It'll take you through a PayPal payment page where you can choose any amount that you would like to give to support our activities to keep this show afloat, and that's a one-time payment. If you are interested in more than a one-time payment, you can click on the Patreon link that's in the main header bar, or you can go directly to Patreon. Patreon.com/thisweekinscience is where we live. And once there, you can click on the Become a Patron button. This will allow you to choose your level of support and how often you support, whether this is a by-episode way of supporting. So you can support once a month. You can support up to however many episodes we put out every month, 4 to 5 episodes. You can do that at whatever level. And it keeps this show going. It helps us pay for our bandwidth, our hosting, our equipment. It helps everything keep going so that we can be here week after week after week. And the money that you support us with, it really does, it drives the show. It keeps it going. And for all of you out there, whether or not you are helping to support us financially and produce this show, or whether you are buying merchandise that also helps to support the show and share the name of TWIS with people you come across. And if you're just outwardly sharing TWIS with people, acting as an informal marketing department of sorts, you really, in all these ways, are helping us out. And the biggest thing is that you keep coming back here week after week after week for the science. Thank you for your support. We could not do this without you.
And we're back with more This Week in Science.
We are back. Hey, we're going to start off the science part of the show with a little bit of the occult. That's right.
No ghosts.
No ghosts.
Okay.
No ghosts. The occult of which I speak isn't the occult as in supernatural stuff at all. It's actually an occultation, or the passing of of one object behind another so that a shadow plays across the surface of the earth. And what happened? This is a really cool story. At first, when I first saw the story, I was like, oh, that's neat. And then it got more and more interesting the more I saw. So the New Horizons team at NASA has a new target, a distant Kuiper Belt object, way out in the dark, cold reaches of the solar system. It's called 2014 MU69. It's just out there moving through space, and we don't really know anything about it. The only time it has been imaged is once by Hubble Space Telescope. And even then, it wasn't enough resolution to get any idea of really what it looks like, its shape, its size. There's a whole lot that we really need to know about this object that the New Horizons probe, which is flying out past Pluto, out into the reaches of the solar system, outer. Where's it going? What is it going to be looking at? And so to figure out more about this object, get an idea of this target New Horizons is aimed at, they determined the path of the object through the sky, and they figured out that it was going to be passing in front of a distant star. And what they did is they trained a whole bunch of telescopes down in Argentina. They had 5 telescopes trained on this star, way out there. And they went to look for the exact moment that the light from that star was blocked. It's a brief blip in time. There's a star that blinks in and out of light. And as it blinks out, what is happening is this MU69 is occulting the star, passing in front of the star, and the shadow. I mean, you think of a shadow as like, oh, look, my shadow on the ground, and it's this big thing. This is a shadow from millions of miles away. This shadow was the shadow of MU69 passing over the surface of the earth, the shadow that was cast by it passing in front of this distant star. In order to be able to see the shadow, they asked Argentina to help them out. And in the process, Argentina shut down a highway for 2 hours so that they could watch. They had street lights turned off so that there would be less city light pollution of the night sky. They had people basically worked together. Communities in Argentina worked together to make this visualization, this view, possible for NASA. And so it's pretty amazing that the goodwill of the Argentinian people are helping with our space exploration and the New Horizons project.
I can't imagine what that would be like. Somebody saying, okay, we're going to close down 19th Avenue in San Francisco for a couple hours. There's this really important thing happening. Everyone will understand. Yeah.
I know. And then they have, in addition to that, the other people, like in some areas, they parked trucks to act as windbreaks in areas so that the wind would be less blowing onto the telescopes and their recording equipment. So a huge collaboration and cooperation internationally to be able to allow us to see this object pass in front of a star. And now, based on this blip of data, it's actually going to be a lot of data, because from this blip we will be able to get information about the size and the shape of this little object that New Horizons is headed for.
This is the part of space science that hurts my brain. And just, it's beyond what I can understand or even appreciate, is that there's this little just wink that means so much and is going to inform so much. And that someone can see that and go, you know what that is?
Yep.
Space science, fascinating.
It is fascinating, and I can't wait. I mean, it's going to be a while yet, but coming in New Year's Day 2019, we can expect New Horizons to fly by this MU-69 and to actually start sending back much more information. But now we will have more information with which to prepare the New Horizons mission for its intended target. And then this is more crazy space science, which I love so much. So another part of NASA is interested in studying the space around our planet, right? So we have, because of our magnetosphere, we have a plasmasphere. This plasma is made up of charged ions and electrons that have been charged, and they get activated even more by solar winds and also by movement of the magnetosphere and all sorts of different things. And we need to know a little bit more about how this area of space works, how it's influenced by solar weather. That this will help us in our placement of satellites, in our understanding of how satellites and spacecraft might be affected, how our communications could be affected in situations where this area around our planet is moving around and being impacted by things. What impacts it? What happens then? And what's going on? So the researchers at NASA's Goddard Space Flight Center, who are working on with Van Allen probes to probe the Van Allen belts around the planet, have been recording these electrons and ions, the high frequency movement, the waves that take place in the magnetosphere. So as solar weather comes through, as things happen here on Earth, waves are set to action. They're called plasma waves, are set to action within the magnetosphere. And they can take these waves and record them and then boost the signal a little bit so it's in an audible phase so that we can actually hear the sounds of different areas of space. So there is a type of wave that takes place in an area where, let's see, where to say, it's when lightning hits the ground, the electrical discharge can trigger a type of wave called a Whistler wave, a Whistler mode plasma wave. And these waves can escape beyond the atmosphere to the Earth's magnetic field lines between the north and south poles. And the lightning creates a range of frequencies. And since higher frequencies travel faster, the wave howls with a falling pitch. And so it's called a whistler wave. And then there's
That sounds like there's a space battle going on out there.
it
Sounds like
Pew, 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 pew.
does.
if a frog and a laser had a baby.
Then there are other waves that are called chorus radio waves.
That sounds like a frog, for sure.
And these occur in a different area of the plasmasphere, and they have an upwardly moving frequency.
Sound like Pacific chorus frogs. So it's interesting they're called chorus waves.
Right? It is interesting that they are called that. But so the story here is that they are using these waves and the sounds and understanding the dynamics of the waves themselves to get a better, clearer picture of the structure of the magnetosphere and how energized particles move within it and through it. And by being able to create these audible files, it gives a little bit better idea of characterization for different segments of the magnetosphere for further investigation, which is super fun. The whistlers, the chorus waves, and then there's also a hiss wave. And it's basically, it sounds like radio station static. And the hiss waves, some scientists think are also caused by lightning strikes, but others think it could be caused by chorus waves that have leaked into a different part of the plasmasphere.
Nobody likes a leaking chorus wave.
Yeah, and the chorus and hiss waves actually are shapers of the Van Allen radiation belts, which are these high energy particle belts that encircle the planet. And so these waves, the waves of these particles actually interact with the Van Allen belts and change the structure, the shape of the Van Allen belts. So, and other parts of the near Earth environment. So these waves are very interesting and important, and yeah, it's interesting things to study, right?
Yeah. I kind of want to make some of those sounds my new ringtone.
Pew, pew, you should. And people will say, is that a chorus frog? And you'll say, no.
No, that's our magnetosphere.
That's right. That works. And then my final intro story is actually one that I think is super fascinating. Researchers at Harvard University have taken CRISPR and they're using it to turn cells into data storage devices. Not just data storage devices, but records of changing information over time. And to show that their concept works, that this archival aspect of DNA, data in DNA could work, they are employing CRISPR. And part of how they're doing that is they are understanding that CRISPR goes in and hacks apart DNA. And the DNA and in hacking it apart, they usually, the natural system, there's a viral spacer that gets viral DNA that gets put in the bacterial cell. But in the case of this experiment, what they're doing is they're not putting a virus in, they are going to be putting DNA of their choice into the cell. And the DNA that they have chosen to use is based on the very first moving picture. Edward Muybridge, right? Yeah, Muybridge, human. He took the video of a jockey on a horse.
It wasn't video. It was
still pictures in a row that were sequential. And
this was a bet. He was hired to settle a bet by Leland Stanford. Most artists depicted that when the horses were fully outstretched, all the legs were not touching the ground, and that was the only point. And by taking these still shots, he determined actually it's when all the legs are tucked up underneath is the only point in which the horse does not come in contact with the ground. Everywhere else, there's at least 1 foot in contact.
And so by taking the idea of the sequential images that Muybridge used in the very first motion picture, they took bits of information from these images, the same exact images, turned them into DNA, used CRISPR to put each image. So like day 1, they used CRISPR to put the first image of DNA in the E. coli. Day 2, they used CRISPR to insert the second image. Day 3, the third image. Day 4, the fourth image. Day 5, the fifth image, until they had all of the images in DNA in this E. coli bacteria. And then they were able to take the E. coli and sequence its DNA, and then take that DNA and play it back. And it played back the movie with about 85% accuracy.
Right.
What?
So it wasn't completely accurate, but it was very, very accurate in its output. They were able to translate from image to DNA to putting the DNA in a bacteria in a sequential way, take the DNA out, sequence it, and play back the movie.
So what we're talking about is a potential for the world's smallest thumb drive. Is that right?
Kind of. I mean, yeah. I mean, the idea they're thinking that maybe it could be used to record the activities of what's going on inside of cells, that maybe you could use a cell, a bacterial cell, to be a recorder inside the body, to be able to record different states or different moments in time. That this could be, yes, it could be a DNA thumb drive. That not only is DNA a good storage medium, but it also could work for sequential information.
Right.
Or you could genetically engineer somebody to have neurons that contain the Library of Congress.
Right. And what George Church, who was involved in this study, was saying is that maybe one bacteria itself wouldn't have such a high data storage capacity, but a whole population of bacteria. And suddenly, you could be storing the Library of Congress and on an agar plate with a population of bacteria.
Nice. Oh, that makes school easier. So we're going to pass around art history lollipops to everybody. Just give it a couple licks, and within a week, you'll have it.
Yeah. Yep. So anyway, this is a kind of a proof of concept of their idea, and they're going to focus on establishing molecular recording devices in not just bacteria, but other cell types, on engineering the system so it can memorize biological information. Like I said, Seth Shipman, who is also involved in the research, said one day we may be able to follow all the developmental decisions that a differentiating neuron is taking, from an early stem cell to a highly specialized type of cell in the brain, leading to a better understanding of how basic biological and developmental processes are choreographed. Yeah, it could also lead to methods for generating cells for regenerative therapy, disease modeling, drug testing, all sorts of things. This is it's not just a, a movie in DNA. You might think that this was a whim and kind of like a haha showing off what we can do, but this really is potentially a very big step in the direction of information storage for the future and recording for the future.
Nice.
Yeah, it's pretty. It's a pretty big thing. It's very exciting. Hey, Justin, it's your turn. What you got?
I have Aboriginal people. Aboriginal people have been living in Australia for at least 47,000 years, which is a really long time, considering that Europeans who are now in Europe have been there for 5,000-ish years. But it turns out they've been there even longer, 65,000 years, which is a really longer time than 47,000. Researchers made the discovery at an existing site, but deeper down, where they found more than 10,000 artifacts in the lowest layer of the site. Quotey voice, the site contains the oldest ground edge stone axe technology in the world, the oldest known seed grinding tools in Australia, and evidence of finely made stone points, which may have served as spear tips, says Associate Professor Chris Clarkson from University of Queensland. Most striking of all, in a region known for its spectacular rock art, are the huge quantities of ground ochre and evidence of ochre. Is it ochre or ochre? One's like a
Ochre?
Ochre.
ochre. Processing found at the site from the older layer continuing through the present. The dig discovered an upper jaw fragment of a Tasmanian tiger that was coated in red pigment, giving them some insight into the fact that they had some sort of custom about doing such things back in the really oldie time days of Australia. Dating carried out by Professor Zenobia Jacobs at the University of Wollongong revealed that Aboriginal people lived at the site at the same time extinct species of giant animals were still roaming around Australia. This includes marsupial lions, the largest meat-eating mammal known to have ever existed, a 10-foot-tall chicken-like bird, Dromorny, which they say looked like a giant emu, but was much more related to fowl. So more like, a giant chicken. And Diprotodon, the largest known marsupial ever to have lived, 10 feet from nose to tail, standing 6.5 feet tall at the shoulder, weighing in at around 3 tons.
Cute.
And interestingly, Queensland, there's claims in Queensland to have been depicted in some cave art about 45,000 years ago, 46,000 years ago, which was also sort of in contention because I think they thought this thing had died out before people got there. So, as well as many, many others, right? So also Homo floresiensis, the little Indonesian hobbit folk, not too far away, would have been around at this time. So there's a whole avenue of potentiality of that contact. But yeah, Aboriginal people of Australia now at it for, what is that, an additional 18,000 years?
Nice. Yeah. Set the dates back.
Yeah.
I think what is this? We just need to dig more. I feel like recently this is like every story you bring on this. It's like, and humans were found in North America longer ago, and humans were found in South America longer ago, and Africa longer ago, and Neanderthals longer ago,
Siberia longer ago. Like they're everywhere longer ago. Yeah, the history just goes back much, much further. And again, humans, we go everywhere.
Yeah,
we go everywhere. Wow. And according to this current study, we may be going a little bit sooner than expected. Penn State environmental engineer Professor Bill Burgos and his colleagues studied sediment samples collected from a reservoir in western Pennsylvania. Hey, that's where we were. Quoty voice, we inserted a tube in the sediment like you would put a straw in a Slurpee or slushy. You put your thumb over the top of the straw and you pull it out. In this case, they used agricultural drain pipe as the straw, plastic caps and tape to seal it. And they collected sediment samples, which were immediately frozen to preserve the contents, brought back to Cape Environmental Engineering Laboratory at Penn State. Once in the lab, the researchers pushed out the samples like a push-pop ice pop. Like a push-up ice pop. You know those little what do they call them? Pop-ups.
Push-ups. Yeah, pop-ups, push-up.
And they cut them into slices. They split them up into different sections. They ran different analyses on them. So there was also some research collaboration with Colorado State University. They looked for high radioactivity signatures and measured the pore water, P-O-R-E water, of the radioisotopes to determine the age of the sediments. They also tested the major mineralogy, particle size, grain size. They created a full profile of the sediment, dating it, sizing it, everything. The results determined that the discharge from oil and gas wastewater as the results of fracking have in fact impacted water quality, sediment quality on a much larger scale than previously thought. Now, this is according to the U.S. Energy Information Administration. Hydraulic fracturing accounted for more than 1/2 of U.S. oil production, 2/3 of U.S. gas production in 2015, and this number is expected to go up. In 2015 alone, Pennsylvania's unconventional fracking gas wells produced nearly 1.7 billion gallons of wastewater. While there are facilities dedicated to treating the wastewater before its release, that treatment may be leaving plenty of the pollutants well intact. Yeah, so large quantities of oil and gas wastewater with high loads of chloride, barium, strontium, radium, and organic compounds were found in high concentrations in the sediment.
All those EMs can't be good.
Yep. There was 2 important types of organic contaminants were found. Endocrine disrupting chemicals and carcinogens were amongst them.
Those 2 are neither of those are good.
Not what you want in a reservoir sediment.
No.
A previous study conducted by these folks found that radium levels immediately downstream from one plant were roughly 200 times greater than in sediments located upstream of the facilities. Current study demonstrates that elevated levels were found as far away as 12 miles downstream from treatment plants. They're next going to be heading off to north of Pittsburgh, I guess. There's, which hasn't yet been tested. There's a major reservoir that feeds the population of Pittsburgh that has upstream of it some of these wastewater treatment things. That area of sediment hasn't been tested, so that's where they're going next to see if it's made it all the way down to that reservoir. One of the things they say is difficult too is there is nobody putting constant 24-hour every day, every year monitoring in the streams downstream of these. There's not a whole bunch of probes in there constantly monitoring the water downstream of this. And if you went in once a month, you wouldn't know when they were discharging. You wouldn't have, you're always going to be there at the wrong time. So this decision, this idea, this concept of going and checking the sediment downstream is really kind of brilliant because it allows you to look over 5, 10, 15 years of activity with one plunge of your straw. Right? So a brilliant way to tackle something that up till now there's not been a real decent way to monitor or observe what's going on.
Well, I'm glad that we have new observation methods. I'm not very excited about the results, but the upside to this is that knowing how and where the contamination is occurring, knowing the extent of the contamination, greater, mitigation can be applied appropriately. as opposed
Well,
to we don't really know what's going on and we'll slap a
we're-
Band-Aid on over here because regulations say we have to. Now, if this can move forward, then regulations can be tightened up. Processes can be made a bit cleaner. I mean, we'll see where it goes.
But it's oil and gas, so they're probably not going to do anything about it.
This is what
But
we
it's
know.
better to know the danger you're in
Yeah.
than to see everything's fine.
Yeah, exactly. I think that's a point I was trying to make.
Okay.
And speaking of danger,
Yeah.
it's time for Blair's Animal Corner.
She loves our creatures, great and small. Biped, millipede, no pet at all. Wanna hear about animals? She's your girl. Except for giant pandas and squirrels. Animal Corner.
What you got, Blair?
Let's talk about birds. Birds are doomed.
Dude, wait, what? I thought birds were gonna survive everything and everywhere, and they're like they live everywhere.
Right,
Why are
because
birds
they
doomed?
can fly.
Yeah.
Well, I have 2 stories this week indicating that perhaps some of these birds might have a larger impact to worry about than something that they can fly away from. So the first is actually about seaside sparrows. And this research is coming out of University of Georgia's Elizabeth Hunter, although she has recently moved to University of Nevada, Reno. She wanted to look at seaside sparrows' nesting behaviors. That's because they go and they nest on the seaside, hence seaside sparrow, which means they're at a greater risk of flooding from sea level rise. So, yeah. So a flooding is a risk. There's other risks that are keeping them down by there. So when we burn fossil fuels like coal, oil, or natural gas to get around or to make energy, it releases carbon dioxide, makes a heat trapping blanket. The heat trapping blanket warms the earth. The thermal expansion of ocean waters causes sea level rise. And then also, as we were talking about last week, the glaciers trapped on land, when melted, pour into the oceans and also contribute to sea level rise. So sea level rise is something that we are seeing currently happening, and the exact effects of it we're not sure about because there are so many different factors adding to it. So as sea level rises and these seaside sparrows have to move up the bank with their nests, there's something keeping them from moving out of the flood zone. And that is predation. So these guys are spending this time so close to the water so that they are less at risk of being eaten, and their babies are less at risk of being eaten. So when sea level rise is taken into account, you would think they would move further up, but that isn't really happening. And that's because the risk of predation is actually higher than the risk from flooding. They would rather be flooded out than eaten. So
I'd rather drown than be eaten. This is a rock in a hard place.
Exactly.
It's better to run and hide than be eaten. That's how it starts. Yeah.
Yes, absolutely. So currently, nests are more likely to be eaten than flooded. However, predation and flooding are acting synergistically, meaning that estimates of the negative effect of sea level rise on nesting success of seaside sparrows or other species are likely underestimated because they're not also considering the negative effect of predation on flooding risk. So you have 2 scenarios here. Either the seaside sparrow gives up on hiding from predators, moves up, gets eaten even more, or they stand their ground and now the risk of flooding is increasing. Either way, you said it perfectly, Kiki, they're caught between a rock and a hard place. They are they're in trouble no matter what. So now the question is, can we give them more seaside habitat further up? Can we do something to buffer their space so that they can move away from the rising tide without getting eaten? And that's why research like this is so important. It's so we can identify what the threats are and what the motivations are. So right now we know, as it stands, the main motivation is to keep from getting eaten. And if that's the case, if we can help seed these plants that they're hiding in higher up the bank, perhaps we can help save this species.
Yeah, and another study that just came out like today or yesterday suggests that birds in general, that a period of quiet climate, like relatively little climate change for a long time, allowed birds to diversify into the many species that we now know. And as we look forward and basically are expecting a period of very rapidly changing climate around the globe, what is that going to mean for the species that are now here, and how many will, like this seaside sparrow, how many will persist and how many will not?
Right.
And
but this is also a good reminder to just the fact that saving seaside habitat and marshlands, that's so important to so many species. It's important to mitigate the effects of sea level rise because it actually reduces the amount that that banks are pounded in those marshes. It helps filter water. It's a carbon sink. All these things we benefit from salt marshes and from seaside habitats like this, estuarine habitats. But on top of all of that, it also is a home to animals that have adapted to live in that specific teeny tiny space. Yeah.
I think with the increased pressure on birds, there's always just going to be one solution, at least one thing that we can all do.
I know where you're gonna go. I know where you're going.
There's one thing that we can all do.
I know where
to
you're
help
going.
take at least some of the pressure off of the birds.
Oh, the cats.
Yep.
Keep your cats indoors.
I mean, it's a good point. Keep them
That's
indoors.
what
Keep your cats indoors. If you can't have an indoor cat, don't have a cat.
Yeah.
There we go.
Yeah. You're right. And we can leave it there. Moving on to other threats to birds besides climate change. Why didn't the bird cross the road?
Wait, what? I thought the bird did cross the road.
In this story, it didn't.
No.
Yes.
What?
So we know roads are a huge barrier to a lot of species, but we usually think about the ones that have to walk on land. For a long time, it's been conventional wisdom that birds can fly over freeways and highways. Makes sense.
Yeah. Whereas
So
snails have a really hard time.
Right, as do salamanders. So this has been thought to be something that actually doesn't contribute too much to habitat fragmentation. When you cut up a habitat so that in theory a species has the right amount of surface area, but it's separated by highways, buildings, all these sorts of things that actually cut off access. So we, for a long time, have thought that birds are not as susceptible to habitat fragmentation because they can fly. Well, a recent bit of research from Griffith University in Brisbane, Australia, found by studying birds in the wild on varying sizes of roads and varying sizes of birds, that they are indeed affected by roadways. Fewer bird species and individuals of each species were found near roads, but also they were less likely to cross the roads the wider they got. So they tested 2-lane, 4-lane, and 6-lane highways, and they tested mostly based on bird size. And so looking at all of these variables and just watching the birds, first of all, they were very careful to pick spots where there's similar brush and similar habitat on either side of the road, because that's where the birds are more likely to cross. And then they found fewer bird species and individuals of each species crossed the 6-lane carriageways, as they call them, than the narrower 2- and 4-lane carriageways. But when they looked at the different body sizes and bird types, it was the smaller forest-dependent species that showed the biggest difference. So the reasons for this, they believe, are more than just fear of being hit by a car, although I would assume that is some of it, because they're these fast-moving, weird things.
And also, with the mention that the larger the road, the larger the effect, you've got a big barrier with a lot of things that are crossing, that are moving very fast. So it's going to be like, aha, that's just big. I'm not going to go there.
Right. So the other side of this is fear of predation. And it's because the forest is safe. The forest is home. The forest is shelter. That means that if there are aggressive predators, including other birds in the area, going out into the wide open to cross the freeway could be a big giveaway and a huge risk.
Interesting.
Yes. So knowing all of that, how do we reduce this effect? So first of all, this completely changes the way that we manage wild bird populations. Because if we know this, we have to take that into account when we're assessing habitats. But now how do we fix this? So for example, I mentioned the salamanders. Down in Stanford, California, they found that the endangered tiger salamander was not crossing the freeway and getting hit a lot on the freeway right by the Stanford campus. And so they made a salamander tunnel, and the salamanders use it. They go under the freeway. And now salamanders are not hit by cars. Their habitat is no longer fragmented. So there are ways that they could still make these similar pathways for birds, but you'd have to do it a little bit differently for birds than for salamanders. Most likely it would be an overpass that is full of vegetation. Lots of cover for these guys. Then it would have to be wide enough that they weren't pushed into all one space. So that's something to keep in mind, but also identifying what times of day or year that it's used as a thoroughfare and reducing or changing traffic patterns at that time of year. So there's lots that we can do with this information, but ultimately birds do not want to cross big highways, even though they can fly.
So the joke just needs to completely change.
Yes. Why didn't the bird cross the road? Because it was 6 lanes wide.
No, because it didn't want to get eaten. Yeah, but this gets at the general problem of habitat fragmentation and species diversity that for years researchers have noticed that the more we fragment habitats, that we chop down part of a forest so that we can make room for agriculture, so that we can build a town, so that we can put a road in. We change the habitats, we fragment them so that what used to be large, continuous areas of habitat now are no longer continuous. And as this study so nicely demonstrates, that the birds aren't moving. And the reason the diversity is going down and the reason the diversity is not being maintained is because of effects like this, these edge effects and the predation deterrent.
Absolutely. Yeah.
Interesting study, Blair.
There we go.
And very last about squirrels.
Yes, squirrels. Squirrels. There's one main reason I don't like squirrels. It's that they're not trustworthy. You should never trust a squirrel.
But they're so cute.
They are indeed cute, but they also have a lasting memory. Squirrels, it turns out, have a long memory for problem-solving techniques, and they can apply them to new situations. From University of Exeter, they found that gray squirrels quickly remembered how to solve a problem they had not seen for 22 months. 5 squirrels were given a task identical to one that they had tried 22 months earlier, in which they had to press a lever to get a hazelnut. In their first experience, they had to practice. It took an average of about 8 seconds in their first attempt. They finally honed it down to about 2 seconds for them to press the lever and get their nut. 22 months later, it took them 3 seconds.
Wow.
Yes.
They're like, we got this.
And what's more, they've also found that if they used a new experiment, a new lever-based technique to get the hazelnut, they still were able to do it. They were neophobic. They were scared of this new thing. They hesitated there for about 20 seconds, but once they started on the task, it took them about 2 seconds. So they were able to apply the technique they learned previously to get there. So
wait, why does this make you not trust squirrels? This sounds like awesome evidence of squirrel intelligence, squirrel memory. This is fantastic.
They use this to outsmart us, Justin. So that's one of the things that the researchers kind of pose here, is that this might be a result of being an urbanized animal, of living around and near humans. We have a lot of ways that we try to keep our food away from squirrels. We have squirrel excluding bird feeders. We have all these sorts of things, trash cans that are not supposed to be openable, and squirrels learn how to get in and get this food. And then the second they see something similar, in they are right away. So this is a way that these guys have figured out to problem solve in an ever-changing environment like an urban one. So kind of the converse of the birds we were just talking about, where they have evolved to a very specific niche. These squirrels are kind of good at all of it. They can learn how to solve these problems and apply that problem-solving skill to new problems. So I say that I do not trust squirrels because they are very good at what they do, which means you are likely to have a run-in with one in a public place, and I don't like it. But bottom line, they're very good at learning. They have a good memory. There's a lot going in that little rodent brain.
There is a lot going in that rodent brain, and as many have shown before, it is possible to get squirrels to learn very difficult tasks, to be able to get bird seed or get food rewards. And there are many videos available of obstacle courses that people have set out to keep squirrels off of their to keep squirrels busy. I don't know if it's keeping the squirrels busy or keeping the people busy, but there are many obstacle courses that I've watched over the years as people have set them up in their yard and train the squirrels step by step to be able to solve the obstacle course in order to get food.
Oh my
So
gosh.
I'm not really surprised.
Yeah. Yeah, and to answer the
Squirrels are
question
smart.
in the chat room from Hot Rod, do squirrels really forget where 80% of their food is hidden? No, they actually scatter their food every year, and their memory for their locations of hidden food is excellent, according to Professor Stephen Leah of the University of Exeter. So actually, it's not necessarily that they forgot where it is, it's that they're saving it for later.
Yep.
You know exactly where it
They
is.
know exactly where it is. That sounds about right.
Yeah, can't be trusted. They're up to no good, I'm telling you.
I think that that's great. They're just planning for the future. These are the squirrels are just they're good at getting food and applying skills in different situations.
They're planning on breaking into my house and stealing my lunch. That's all I know. And
They might
taking
be.
down power lines and
Well, just don't give them a third arm. Let's not do
Let's
that.
not give anyone a third arm.
Wait, what?
No, thank you.
So, a new movement in robotics is something called Octo, spelled AUCTO, and right now it's at a prototype stage, and it's a robotic arm that is strapped onto a carbon fiber vest or skeleton that a worker can potentially wear on their outside of their clothing or under their clothing, that supports this arm. And the arm basically is like an extra limb that would come out of your shoulder that could grab things and be placed in different places to either support your weight to make it easier for hands-free work, or to hold things for you if you need an extra hand. And there's a wonderful video that's been put out by Science AAAS, and that shows some of the things that this arm can do. Now, the arm itself is jointed so it can articulate in multiple directions. The end looks like it has something like a plunger on the end of it, but it's not a plunger. It's actually more like a boxing glove that's filled with beans and coffee.
Ew.
That when the air is sucked out of it, it's smushy, and you can put it up against something, and then you suck the air out of it, and it'll hold on to whatever you've put it
Like a
on.
suction cup. Kind of
It's
thing.
like, yeah, kind of like a suction cup. And so anyway, it's the kind of thing that could be used as an extra arm to hold something heavy up over your head, to hold you up. And it has its own gyroscope and its own brain of sorts to stay in position, in whatever position you want it to be in, even though you're moving around. So it has its own degrees of freedom for movement. And now, again, it's called.
That's what I need. One more
Octo.
appendage with a mind of its own.
So
Yeah.
Doc Ock is real, is what you're saying.
that's
He's
what it
coming.
is.
That
Exactly.
Doc Ock is coming.
That's exactly what that
He'll
was.
be right here.
Good call.
That's right.
We just need a radioactive spider now, and we'll be all set.
So yeah, extra limbs, you guys, they are coming soon. And in the other, on the other side of world robot domination, there are the robots in our lives, the AI, that are going to be thinking for themselves, already do think for themselves very often, that work with us and for us, and we don't want them to hurt us at any point. And so people thinking about robot philosophy and development are trying to figure out how to basically keep robots from killing humans and hurting humans, when the self-driving cars need to keep occupants safe and protecting themselves from damage. That robots need to care for the elderly and adapt to situations when the owners might be at peril, but then the robots need to protect themselves as well. So once a robot can think for itself, how are you going to teach that robot that it needs to not just think for itself, but for others, for humans as well? And so years ago, people came up with an idea of empowerment, empowering robots to help them protect and serve humans. And this idea of empowerment comes from this idea of the concept of harm being kind of complex and context specific. And how do you explain harm to a robot? Do no harm, or Asimov's rules, or obey humans and don't harm a human. But what does that mean exactly to a robot? So the team developed this empowerment, meaning being in a state where you have the greatest potential influence on the world that you can perceive, according to Christopher Salge, who's a scientist involved in this study. So for a simple robot, he goes on, this might be getting safely back to its power station and not getting stuck, which would limit its options for movement, empower itself. For a more futuristic human-like robot, it would not only include movement, but could incorporate parameters that are more like human-like drives. And in 2005, they developed this. And now they are expanding it to ask the robot to also seek to maintain a human's empowerment.
Why on earth would we want to infect a robot with human type thinking? This is the whole thing we've been trying to get away from, and calling a civilization and not being animal brained about everything.
Right, not being animal brained, but not being animal brained could lead to the demise of humans, because a robot thinks that humans aren't doing something correctly, or the most efficient way to do something doesn't involve humans.
That's what animals think. That thing will either eat me, or I have now the opportunity and leverage to eat it, and therefore I will. That's human thinking. That's not how the robots will conceptualize the planet, unless we teach them to. And then we're going to be in trouble.
Yeah, so another researcher named Polanyi says they wanted the robot to see the world through the eyes of the human with which it interacts. Keeping the human safe consists of the robot acting to increase the human's own empowerment. In a dangerous situation, the robot would try to keep the human alive and free from injury, We don't want to be oppressively protected by robots to minimize any chance of harm. We want to live in a world where robots maintain our empowerment. And so they say that it's an altruistic concept, this empowerment, and that it might allow robots to adhere to the spirit of Asimov's 3 laws as we move forward. Driving ethical behavior in robots. World robot domination. They're going to have ethics and be empowered soon, everybody.
And 7 arms.
But no, we're going to have all the arms. Maybe we can use the robot arms to fight the robots.
But what if the robot arms start thinking for themselves?
Just leave the robots alone. Let the robots be robots. No robot has intentionally harmed a human being.
That you know of.
That I know of. No, like that's it's whenever it happens, it's either human carelessness or human intention. Yeah. Robots are faultless.
I think it's just a fascinating thought project. We have people like Elon Musk and Stephen Hawking, who are warning of the advent of the rise of the intelligent machines and what that's going to mean for humanity. And so if we can program in some, make sure that we're maintaining the human species as we move forward with our development of these robots. I mean, that's, this kind of theoretical work is going to be important in our future conversations and also in the regulatory structure of artificial intelligence and robotics as we move forward. Yeah. Does that do it, you guys?
I'm all done.
That does it. Oh my goodness. How do we make it this far? How did we make it this far, you guys? All the way to the end of the show. We've had an interview. Wonderful guest, Jessica Hebert. And we are now, once again, at the end of the show. And I'd like to thank everyone for watching and for listening. And I would like to thank our Patreon sponsors. Thank you to Thunder Beaver, Paul Disney, G. Burton Lattimore, John Ratnasamy, Richard Onimus, Byron Lee, E.O., Kevin Parachan, Jacqueline Boyster, Tyrone Fong, Andrew Groh, Keith Corsell, Jake Jones, Chris Clark, Richard, Charlene Henry, Brian Hedrick, John Gridley, Stephen Bickle, Kevin Railsback, Gerald Sorrells, Ulysses Adkins, Dave Friedel, James Randall, Bob Calder, Mark Mazzaros, Ed Dyer, Turner84, Layla, Marshall Clark, Larry Garcia, Randy Mazuka, Tony Steele, Gerald Onyango, Steve DeBell, Kyle Washington, Greg Guthman, Time Jumper 319, XV, Daryl Lambert, Haroon Sarang, Alex Wilson, Jason Schneiderman, Dave Neighbor, Jason Dozier, Matthew Litwin, Eric Knapp, Jason Roberts, Richard Porter, Rodney, David Wiley, Robert Aston, Sir Frankadelic, Christopher Rappin, Dana Peterson, and then I scrolled it funny. Paul Stanton, David, Brendan Minish, Dale Bryant, Aurora Lee, Todd Northcutt, Arlen Moss, Bill Kersey, Ben Rothig, Darwin Hannon, Rudy Garcia, Felix Alvarez, Brian Hone, Orly Radio, Brian Condren, Mark, Nathan Greco, Hexator, Mitch Neves, Flying Out, John Crocker, Christopher Dreyer, RTM Shuwada, Dave Wilkinson, Steve Mashinsky, Rich Gramus, Gary Swinsberg, Phil Nadeau, Braxton Howard, Sal Good, Sam, Matt Sutter, Emma Grenier, Philip Shane, James Dobson, Kurt Larson, Stephen Insom, A Honey Moss, Mountain Sloth, Jim Drapeau, Jason Olds, James Paul West, Alec Doty, Aluma Lama, Joe Wheeler, Dougal Campbell, Craig Porter, Adam Mishkan, Eric Luthen, Marjorie, David Swimmerly, Tyler Harrison, Columbo Ahmed. Thank you for all of your support on Patreon. And if you out there are interested in helping us produce TWIS, you can find information at patreon.com/thisweekinscience. You can also just simply help us out by telling your friends about TWIS. Tell everybody you know. Shout it to the rooftops, or maybe make a flyer and stick it on a telephone pole. But tell everyone about TWIS. And on next week's show, we will be live once again, broadcasting online at 8 p.m. Pacific time. TWIS.org/live, where you can watch and join our chat room. Also at facebook.com/thisweekinscience and on our YouTube channel. But don't worry if you can't make it. You can always find past episodes at twis.org/YouTube or twis.org.
Thank you for enjoying the show. TWIS is also available as a podcast. Just Google This Week in Science in your iTunes directory, or if you have a mobile type device, you can look up TWIS, the number 4, Droid app in the Android marketplace, or simply This Week in Science in anything Apple marketplacey.
For more information on anything you've heard here today, show notes will be available on our website. That's at www.twis.org, where you can also make comments and start conversations with the hosts, as well as other listeners.
Or you can contact us directly. Email Kirsten at thisweekinscience.com, Justin at twistminion@gmail.com, or Blair at blairbaz@twist.org. Just be sure to put twist, TWIS, somewhere in the subject line, or your email is very likely to be spam filtered into oblivion. You can also hit us up on the Twitter, where we are at Twist Science, at Dr. Kiki, at Jacksonfly, and at Blair's Menagerie. We love your feedback. If there's a topic you would like us to cover or address, a suggestion for an interview, a haiku that comes to you in the night, please let us know.
We will be back here next week, and we hope you'll join us again for more great science news.
And if you've learned anything from the show, remember,
It's all in your head.
This week in science. This week in science. This week in science. This week in science, it's the end of the world. So I'm setting up shop, got my banner unfurled. It says the scientist is in, I'm gonna sell my advice. Show them how to stop the robots with a simple device. I'll reverse global warming with a wave of my hand. And all it'll cost you is a couple of grand. 'Cause this week's science is coming your way. So everybody listen to what I say. I use the scientific method for all that it's worth. And I'll broadcast my opinion all over the earth. 'Cause it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in Science. This Week in Science. This Week in Science. 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 I've got one disclaimer, and it shouldn't be news, that what I say may not represent your views, but I've done the calculations and I've got a plan. If you listen to the science, you may just better understand that we're not trying to threaten your philosophy. We're just trying to save the world from jeopardy. Jeopardy. And This Week in Science is coming your way. So everybody listen to everything we say. And if you use our method instead of rolling a die, we may rid the world of toxoplasma gondii. 'Cause it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in Science. This Week in Science. This Week in Science. 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 I've got a laundry list of items I want to address, from stopping global hunger to dredging Loch Ness. I'm trying to promote more rational thought, and I'll try to answer any question you've got. But how can I ever see the changes I seek when I can only set up shop 1 hour a week? This Week in Science is coming your way. You better just listen to what we say. And if you've learned anything from the words that we've said, then please just remember it's all in your head. 'Cause it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in Science. This Week in Science. This Week in Science. 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 This Week in 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 Science.
And now is the after show. We have done it again. Another episode not run by robots, but rather by us. Da-da-da, the end of a show. Hello, chat room. How is you going? There is nice time, eh? Oh, this last weekend, I saw Borat for the first time in a very long time. I had forgotten how very funny that movie is. Yeah. Haha, Fata. Yes. The Afterbirth. Depends on what you think is our show. The birth process? Then this would be the afterbirth. I
There you
don't know if I like that analogy. Okay. Ooh, it is 80 and humid. That sounds like a nice hot night.
Yeah.
Ooh, face transplant at Cleveland Clinic. Yeah, that's great. She's going to be on anti-rejection drugs for the rest of her life so that her face doesn't fall off.
Ooh.
Ew.
Pretty soon with stem cells, we can just grow you your own
Yeah,
face
really
back.
I mean, Cleveland Clinic is good at stem cell stuff. They replaced 100% of the woman's facial tissue. Ed, thanks so much for this link. The scalp, the forehead, upper and lower eyelids, eye sockets, the nose, upper cheeks, the upper jaw, and half the lower jaw, upper and lower teeth, part of the facial nerves, facial muscles, and skin.
Yikes.
Wow.
Yucky.
Yeah, it was a 21-year-old woman
Oof.
who she incurred a gunshot wound to the face
What?
when she was a teenager.
Oh, poor thing.
Yeah, and they say recovery's good. She is walking and talking, and they expect that she will be able to eat with her mouth soon.
Oh boy.
That sentence, that part of the sentence in itself speaks volumes to what she's going through right now.
Poor thing.
Yeah, they used surgical rehearsal. The team rehearsed. They did 3D printed models and virtual reality to plan before the surgery. So that would be more accurate. And they had a donor for a new nose, new lips, palate, eyelids, and jaw. Yeah. But still, I mean, how closely matched is that donor? This woman, this 21-year-old, is going to be on popping pills, anti-rejection drugs for the rest of her life. But I mean, I guess you would do that if you needed a face.
Mm-hmm.
If it meant you could have a face.
This isn't like I'm going to give you my kidney. This is somebody died, right? And they were a donor.
Yes. Yeah, no, you don't just give somebody your face.
Here's
Yeah,
my
this is a
face.
donor. This is a donor situation.
Well, like the Google algorithm, like identify them as the other person in selfies?
I don't believe so because the underlying reconstruction, I mean, some of it, I guess with this story, it looks like some of it is, some of this is the upper jaw and part of the lower jaw, and the teeth and the nose. I mean, yeah, I mean, how much of the structure of your face is determined very much so by the underlying bone and the muscles and tendons that are under there. So you could probably take any face and fit it on and it would not look the same because of the underlying skeletal structure.
Right.
But like this says there, they had to replace the upper and lower jaw, teeth, nose. So I don't know. Yeah, I don't know what kind of similarity there would be. I don't think I think that the overall facial structure probably is different enough though, but I don't know.
Yikes.
Yeah, I mean, a face is just a face, right?
Sure.
What?
Yeah. Yeah, totally. Yeah, absolutely.
Yeah, it's an interesting story. Who is asking? Ed from Connecticut is asking, if you could grow a new face, what would you change?
Wow.
I don't think I'd want to grow a new face. I like my face.
Yeah.
I've always been pretty okay with my face. I don't, yeah. When I have self-esteem issues, it's not usually because of my face. And as I
Word
get
man.
as I get older, I'm earning my wrinkly stripes. You
Mhm.
know? I've got this one wrinkle in here. It's that one right there. It's my
I've got one like
my
that.
concentration wrinkles. When I'm really thinking about something, that one's
Mine's not. I don't deem mine being involved in concentration. Mine is more. Did you really just open hand eat yogurt on the couch? Ah!
Why
It's
would
more
you
like that.
do that?
Why would you even think that would be like end well?
Yeah.
Ah!
Oh, Fada got my song reference. You must remember this. A kiss is just a
Face
kiss.
is just a face.
A face is just a face.
Sometimes.
Loquacious one. So maybe we can grow other parts. Everyone has something about their body they don't like. We should just grow those parts so we like them.
I don't think I
Okay.
need more parts.
I don't need more parts, except maybe a third or fourth robot arm. Maybe.
Yuck.
Or be
Yeah.
handy.
Do not sign me up.
Identity 4 says he put something fun in the Dropbox. What is it? I have to hear it. I want to know what's in there. What'd you put in the Dropbox? Oh. Me being silly. That can be used later.
Everything froze.
Thank you, Identity.
Did it? Everything's fine on this end.
Everything's fine here. New parts. Yeah. So isn't that what we're working on? Maybe it would be nice to have an actual new hip instead of a hip implant. You know, I think I'm gonna have hip problems when I get older. Identity.
I don't know,
would love
Kiki.
to
I
make
think
you
you'll
stay up
stay
late.
hip forever.
I'm gonna stay hip. That's
Yeah.
right. I'm hip. I'm hip. Hot rod, gorgeous. So like that, my papa, my grandfather, Papa, he would say that. Gorgeous, simply gorgeous. This big booming, he had this big booming voice. It was great. Gorgeous.
All right, Blair's dropping out because she says we're robots.
I'm not a robot.
We're not robots, but she thinks we are.
Testing.
You sound fine and look
Yeah,
fine.
you're fine to us. We're just robots to you.
You're both
And we
robots
need your
to me
brain.
right now.
I need your brain for research into humans. Okay, well, I think we had a nice run of the show anyhow. I think we had a fantastic guest. Ran like almost a full hour. Yeah, she was fantastic.
Yeah, she was great. I really enjoy having long conversations with the guests, but it keeps us up late and it makes the show very long.
Which is fine, but we can. I think on those nights we can cut short this aspect, the hangout.
Yeah,
I think those are the nights when half our audience, from what I can tell, is already like,
I'm
they're
asleep.
texting the word yawn now in the show. It's time.
It's sleepy time.
So I will go as well. I will see you all.
You're both back just in time for me to say goodbye.
That's right. That's what we were just saying. We were getting ready to say goodnight.
So say goodnight, Blair.
Good night, Blair.
Wait, I got remember if there's anything important that we need to talk. I don't think there is. I think we're just doing a show next week, and there's no interview to worry about. And I've got interviews lining up in August.
Excellent.
Blair, you're coming up for solar eclipse still?
Yes, I am.
Okay, we got solar eclipse in August.
Got my campsite.
And exciting news. I don't know how it's gonna work out, how we'll make it work. But I'm trying to organize some podcasting event things with Tom Merritt. Yeah, from the Daily Tech News Show, formerly of TWIT and CNET, and the maybe live events in the future. Yes.
You know, I love live events.
On the West Coast.
Great.
Yes.
Oh,
Yes.
even better. Yes.
Yeah. November, beginning of November, we're going to be going to Colorado. I haven't heard back about the entomological conference, but just reminding that that's going to be on the calendar beginning of November, probably, unless they call back and say no, but we have to keep it open. And then, and we're going to have Tom Merritt on as a guest, Ed from Connecticut. He's going to be on the show probably August 9th.
Nice.
And calendars. So when should what did we decide? What's our target deadline for pre-orders for the calendar? So I have
pricing. And I have scanned in the first 4 images. So we can post those online for pre-sale anytime.
Okay.
Cool.
Yeah. All right. So let's set a date to do that, because it'll take me a few minutes to actually put together the link and the post and all that kind of stuff.
Great.
Yeah. So let's think about aiming for that, because it would be awesome to send things out in November instead of the last minute like we have been doing. So maybe start pre-orders in, what do you think, Justin? Late August, September?
Yeah.
I think
people buy calendars.
Yes, and I think you can't be too early about it, because we want people to plan on using our calendar so they don't accidentally buy another calendar and then we make a calendar and then it's too late for them to use our calendar.
Oh, I just got a calendar. It's too bad.
Yeah.
So I think mid-August is fine.
All right. Mid-August. We will aim for that. That's a good deadline. Okay.
Great.
Okay, I think that's all the business that we need to chat about at the current moment. Thanks, you guys, for hanging on for a couple more seconds. And I'm glad we're not robots anymore.
Yes.
Yeah. Thanks, everybody, for watching. Hope you enjoyed it all. All right.
Say goodnight, Justin.
Good night, Justin.
Say goodnight, Kiki.
Say goodnight, Kiki.
Okay.
Say goodnight, Blair.
Good night, Blair.
Good night, everyone. Have a good week. We'll see you next week.